So today we're going to investigate multiplying and dividing. So I want you to have a think about what you already know about multiplying and what you already know about dividing. Okay, so have a little think, and in a minute you're going to turn to the person next to you and you're going to say, what do you know about dividing and what do you know about multiplying? So have a think what you're going to say when they ask you. Okay, just turn and sit knee to knee with the person next to you. Okay, and eyes this way. Okay, so boys and girls, multiplying. What are you thinking? Multiplying. Okay, this boy here wants to share. Hands down, listen, see if you agree. Multiplying.
I think that it's when you times stuff and plus stuff.
Times and plus. Hand up if you're agreeing. Hand up if you're thinking something else. Okay, let's see what we're thinking. What are you thinking, gorgeous? Hands down.
When you use a strategy,
But what is multiplying first?
Multiplying is where you... Well, multiplying is where you multiply something. Well, you add 2 to something in the 2 times tables.
So that's a really good... That's going to start us off. Hands down for a second. Hands down for a second. Hand up if you think multiplying is like adding. Who thinks it's like adding? Okay, hands down. Hands in your laps and listen. I'm going to prove to you that multiplying and adding are not the same thing. Why would we have them both if they're the same thing? All right, so I'm going to do a little experiment. I'm really rich. I've got $2. This person's richer. She's got 2 plus $2. How much has she got?
$4.
Plus 2.
$6.
Plus 2.
8.
Plus 2. 10. Plus 2. 12. Plus 2.
14.
Okay, how rich do you feel? $14?
No.
Not very rich? Okay, would you like to feel richer? All right, so were we just adding or multiplying? We were adding because we were adding 2 each time. Now, when you were in year 1 and 2, we told you that that was multiplying, but it wasn't. It was really adding. This is important. Now we're going to multiply by 2. I'm still really rich. That's how we want you to think about multiplication. Not that when you multiply me by 2, there's 2 of me, because that would be adding. All right? When you multiply me by 2, I become 2 times bigger. Okay? And that's multiplicative. Turn to your partner and say, that's multiplicative. Fantastic, eyes this way. So that's how we're going to think about multiplication. Now today we're going to investigate 3 levels of multiplication and 1 level of division. So let's talk about division then. When we multiply by 2, I'm going to become 2 times bigger. So if you divide me by 2, I don't want you to think you're cutting me in half. I want you to think that I'm going to become 2 times smaller. So you made me 2 times smaller when you divided me by 2. So do you think I'm cute when I'm 2 times smaller?
No.
Do you think I'm a monster when I'm 2 times bigger?
No.
And what about when I'm a normal size?
Yeah.
So can you see that how we want you to think? We want you to think multiplicatively. Okay, so this is the first level. I'm going to put up how many levels? 3. And are you going to choose which level you're ready to investigate?
Yeah.
Okay. So the first level is I'm going to think about multiplying by 2. And I'm going to think, is there any 2 times table? Is there any multiplication by 2 that I don't know? Now, when I say I don't know, it means I don't want to work it out by skip counting. Because skip counting is? Adding. And do we want to add or multiply?
Multiply.
Fantastic. So, and also, if we could easily do 2 times 6 by skip counting, but what if it was 2 times 26? Or 2 times 126? You're not going to skip count, are you? All right, so we don't want skip counting. So here's what I'm going to do. I'm going to have a look at these and I'm going to go 2 times 1. I know that one. 2 times 1 is 2. Sorry. So I'm going to put that in my pile that says, yep, I know that one. Now I'm going to try 2 times 2. 2 times 2 is 4. I know that one, so I'm fine with that one. 2 times 3 is 6. I know that one. 2 times 4 is 8. I know that one. 2 times 5 is 10, I know that one. 2 times 6 is 12, I just know that one. 2 times 7, I'm not real sure what 2 times 7 is.
14.
I'm not real sure. Who just said that? Are you going to live with me the rest of my life, and every time I need to know what 2 times 7 is, are you going to tell me?
Maybe.
Seriously? I'm asking you a serious question. Are you going to live with me for the rest of my life? No. So is there any point you telling me the answer? None at all. Who thinks I have to be able to work out the answer?
Yeah.
All right? I have to work it out myself. Now I'm not going to skip count because that's not going to help me with bigger numbers. So I'm going to write 2 times 7. Now I know some multiples of 7, some multiples of 2. A multiple just means that if I multiply by 2, I get that as an answer. So is 6 a multiple of 2? If I multiply by 2, will I ever get 6? What will I multiply by 2?
3.
So 6 is a multiple of 2. Okay? Is 8 a multiple of 2?
Yes.
Is 7 a multiple of 2?
No.
No. So understand what a multiple is? All right, if we multiply by 2, we're going to get it as an answer if it's a multiple. So I don't know 2 times 7, but I do know 2 times 5. So could I partition 7 into 5 and 2? Now can I go 2 times 5? And I know that one. I know that one's 10. Now can I go 2 times 2? And I know 2 times 4, 2 times 2 is 4. Now can I add my 10 and my 4?
Yeah.
And I get 14. And now I know what 2 times 7 equals. And if I ever forget what 2 times 7 equals again, do I have a strategy that I can use?
Yeah.
Now the reason this is such a great strategy is because it's actually using a property of multiplication that works all the time, no matter how big the numbers are. It's called the distributive property. And it's called the distributive property because if I don't know what 2 times 7 equals, can I partition my 7 using addition?
Yeah.
So what I've done is I didn't know what 2 times 7 was, so I distributed my multiplication over addition. All right? Now you don't need to remember the name of that yet. Maybe by the time you're in year 5 or year 6 you'll start to remember the name. But this works no matter how big the numbers are. So if I can do 2 7s, can I now do 2 17s?
Yeah.
How could I partition that? Fantastic. Can I do 2 times 362?
Yeah.
How could I partition that? 360.
62.
Am I still using the distributive property? So see how this works no matter how big the numbers are? So that's the first level. If you think you know all of your multiplication by 2, all of your 2 times table up to 2 times 10, you can do the next level, which is this. You're going to choose a teen number. So I'm going to use my 110 and I'm going to get another number, maybe 5. So what teen number have I made?
15.
Fantastic. So this is going to be the red level. So now we're going to divide. We're going to say 15 divided by 2. Now think about this. If I divide by 2, what fraction am I going to get? Okay, so I've got this piece of paper, but I've only got one. And I want to give the same amount to her as I give to her. So I'm going to... Think it, don't say it. Let everyone else come to the party too. Okay, so I've set it all up. So now am I giving them each one? Or am I giving them each? Half. Did I divide by 2?
Yes.
So when I divide by 2, what fraction do I get? Half. So you are going to, as well as writing 15 divided by 2, you're going to write half of 15. Okay? Now, let's see if we can partition 15. Is 15 a multiple of 2? Is 15 a multiple of 2? No, because if we multiply by 2, will we ever get 15 as an answer? Never. Okay, so what's a multiple of 2 close to 15 that you know? What about 10? Is 10 a good one? Okay, so I'm going to partition this into 10, which is a multiple of 2, and then I'm going to have 5. Now I'm going to do the same over here. So you have to do both of these. Now is 5 a multiple of 2?
No.
Am I ever going to get 5 if I multiply by 2? No. What's a multiple of 2? A multiple of 2 that's close to 5? 3 is not a multiple of 2. A multiple of 2.
4 and 1.
4. Is 4 a multiple of 2? Hello? Is 4 a multiple of 2? Good girl. So I can partition into 4 and 1. So did I just partition into any numbers I liked?
No.
Or did I have to choose multiples of 2?
Multiples of 2.
Now 1 is going to be left over because it's smaller than 2 and I can't partition it into a multiple of 2. So now I'm going to write 10 divided by 2 is, I know that one. What this means is 2 times what equals 10. So 2 times what equals 10?
5.
5. So 2 times 5 equals 10. So 10 divided by 2 is 5. Okay? So over here I'm going to write half of 10. And what's half of 10? 5. So is it the same number sentence? Does that and that mean the same thing?
Yes.
Fantastic. Now 4 divided by 2. What that means is, what do I have to multiply 2 by to get 4? 2 times 2. And over here, half of 4. What's half of 4? 2. Is it the same number sentence?
Yes.
Fantastic. Now we're going to add them together. 5 and 2 is?
7.
5 and 2 over here as well is?
7.
So it equals 7 and we had 1 remaining. So this little r means 1 remaining. Let me fix that. So this little r means 1 remaining. Remainder 1, exactly. Fantastic. So you've got 2 levels on the board. If you demonstrate that you understand this, guess what the next level is?
3.
Multiplying not by 3. The next level is going to be doing exactly the same thing with your 4 times table. And if you can multiply by 4, you're then going to divide by 4. Okay, so hand up if you think you know what you're doing. Hand up if you're going to try the black level. Hand up if you're going to try the red level. Fantastic. Everyone, even if you think you already know this, demonstrate that you know it and you understand it, then we can move you on to multiplying by 4. Okay, so listening to your teacher as you go to your tables.